Next step is to set the flight control. First we see the link data connection interface on the flight controller, which is connected to the remote control. Now let's unplug this wire and put it aside in order to be able to connect the computer. This line in my hand can be connected to the computer and the flight controller. Now plug it into the interface. We now double-click on the computer to open a software for flight controller debugging. So we can start connecting the flight controller. A red dot shown here means that the flight controller is not connected. Then we click on this. We can see that this has turned green, indicating that it has been connected. The number here is the number of the hardware. From these data above, you can see the status of the flight controller, and the first one is the status of the MU. We can see that the compass is not calibrated, the GPS signal is weak, and the voltage is not confirmed. Here is information on frame construction. Here is the remote control information. You can see whether the remote control status is not connected yet. Here are some parameters of the flight. Next to some other data. Now let's click on base, where you can choose the model. We see that there are many models to choose from: 4 rotors, 6 rotors, 8 rotors, and so on. You need to choose according to the actual structure of the model. We generally use this X-type structure, not the cruciform. This is the cruciform. X-type is this: 4 rotor, 6 rotor, 8 rotor. This is also an 8 rotor, with 2 motors up and down, which is also an X-type. This is the X-type. Our current drone is an X-type, 4 rotor, so we have to choose this structure. After selecting this structure, we can click Install to install the location of the flight controller. If the direction of the flight controller is the same as the arrow, choose the first one. If not, choose the other one. There are other options that are backward, left, and right. But we better try to keep the flight controller position consistent with the direction of the drone head. Including GPS is the same. If it is consistent with the direction of the nose, choose the first one. If the orientation is inconsistent, choose another, and you can choose the right, back, and left directions. Here we need to select the position of the center of gravity of the flight controller. Put the flight controller at this point, then the data will all be 0.0. We can see that there are X-axis, Y-axis, Z-axis. Z-axis is up and down, X-axis and Y-axis are flat. We see the X-axis. If the flight controller is placed in front of the center of gravity, the numerical value is a positive number. After the blue, the numerical value is negative. Seeing the Y-axis, if it is placed on the Y-axis and the flight controller is placed to the right of the center of gravity, the data is also a positive number. Put it here, that numerical value is a negative number. Looking at the Z-axis again, if the flight controller is installed below the center of gravity, the value will be a positive number. If the flight controller is placed on the center of gravity, it will be a negative number. Usually, We usually put the flight controller center of gravity and place it in the middle of the x-axis and the y-axis, but the z-axis, this time we installed it above the center of gravity. It can be seen that it is a negative value. It is about 2 centimeters. We can measure it, and then fill in the numerical value. This interface is mainly to determine the flight controller position and GPS position. This interface is some parameters for debugging, and now some data displayed above are some commonly used preset data. Different models need to adjust different data. How do we adjust these data? Now these preset data are relatively stable data. If we want to make the drone more flexible and responsive, we need to continuously increase the numerical value. But if you increase the numerical value too much, it will make the drone tremble again. So we need to add gradually and slowly. Generally we can increase by 10 to 20%, increase by 10% or 20% each time, such as this 50 data, we can increase it to 60. This 100 data, we can increase to 120. Adjust these data in increments of 20%, 10%. The later we will adjustment of the increase is smaller. For example, an increase of 5%, 2%, 1%. Continuous adjustment makes the data larger, and the drone body does not shake but is more responsive. These are some options for the motor to use when testing the motor. If we want to turn off the motor, select the off option, click M1, then the number 1 motor will not turn. If very slow is selected, the motor still does not respond because the speed is too slow. Then we choose medium, click M1, the number 1 motor will turn, then, click M2, the number 2 motor will rotate, continue to click M3, M4, both will rotate, then we can see its structure now. The right side of the drone head is M1, and the motor rotates counterclockwise. The left side of the drone head is M2, the motor rotates clockwise. The bottom left is M3, the motor must be counterclockwise. Bottom right is M4, the motor must rotate clockwise. We need to test whether the actual rotation direction of the motor rotates in the direction shown in the figure. Click M1 during the test to see if the motor rotation direction is counterclockwise. Then click M2 to see if the motor rotation direction is clockwise. Then click M3 to see if the motor rotation direction is counterclockwise. Finally click M4 to see if the motor rotation direction is clockwise. This way we can note all the motors are installed correctly after the test. If it is not correct, we need to rewire. In this way, after debugging, we don't have to worry about the rollover of the drone when we go out for a test flight. Now see the remote control settings interface. The remote control needs to be calibrated. First of all, the remote control is connected with the SBUS remote control. Next we start the calibration. Click this calibration. Then we perform extreme operations on the joystick on the remote control. Center the joystick after calibration and click this again. The calibration is successful. Here are some options for setting channel number 5 of the remote control. The 4 channels state adjust debugged are pitch, roll, throttle, yaw. The 5th channel sets the mode of the drone flight. The setting of channel number 5 can change the flight mode. You can choose manual or attitude. This is for 2AB operation, which is GPS position. Here are some options for the drone out of control. This is automatic return after losing control. This is automatic landing after losing control. Don't choose the last two. There is also a setting on the right. You can choose whether to continue to work after losing control. These are some data from the flight controller. It has 3 IMUs, and there will be 3 MU data. This IMU still needs to be calibrated, which we haven't done yet. This is the compass, and it needs to be calibrated, and we haven't done it yet. This is the GPS. You can see that bad is displayed on it, which is because the signal is not good because it is indoors. This is the barometer, showing some data from the barometer. You can see RTK, not connected next to GPS 1, 2. This is because we don't have it installed. The above is a general introduction to some data of the flight control. Here are some other data, flight speed, etc. Some settings can also be made. Then click ADV on the left menu, and now some advanced settings are displayed, which can set flight parameters and other data. At that time, we will have a dedicated page to introduce how to set these data. The performance mode can be set according to different drones. For example, the drone that is flying more intensely can choose movement. For the more balanced drone, you can choose balanced. It is relatively slow, and the drone used for shooting can choose anti-southeastism. The second is some other settings. This line is about the operation options of the low voltage state. Here are the operating options after PMU failure. Here is the voltage calibration, and the left side is the measured numerical value. In fact, we need to use a multimeter to measure yet. After measuring the numerical value, fill in the right. The following is the setting of channel number 6. You can make some choices through channel number 6. Here is the water pump, which the agriculture drone will use. Below are the settings for channel number 7, whether to use a single pump or double pumps. Here are some settings for liquids. If the liquid is almost used up, you can set the following options. Here is channel number 8, channel number 9. You can set the work at point 80, how to save, how to start work, etc. Here are some settings about the fence. The height can be set to 20 meters and the distance is 300 meters. We can adjust it according to the actual situation. Here are the settings for some other functions such as JRTK, K-box, etc. After the JRTK is installed, these functions must be set to see where the RTK is installed. Some of the above data must be set. If it is the off-the-peg product, it will be set up. The last column of the left menu is the toolbar, which can be upgraded include other settings. This is the description of all computer debugging. These debugging work can also be performed on the ground station on the remote control.